like double angles and like compound angles and all that. So looking at what we have here, right? It says given 510 alpha plus 4 is equal to 0. And then they told you that alpha is between 180 and 360. They're telling us that alpha is between those points over there. So if alpha is between those points over there, then wait a minute. 5 what I determine without the use of a calculator this expression. So anyways, questions like these, right, they're super common, right? I think we might as well read it again because like, why not? So it says here, 510 alpha plus 4 is equal to 0, right? Before we can do anything, right, them telling us that alpha is between 180 and 360. What you want to do first is you want to draw like a Cartesian plane, right? And then in this Cartesian plane, you want to remember that alpha, there's going to be 0 here, right? 0, 90, 180, 270, and like 360 over there. So from this, you just want to keep in mind that alpha, they said it's between 180 and 360. So alpha is like somewhere here. Before you can decide where exactly, before you can like decide where exactly alpha is, you just want to make use of this information. So 510 alpha plus 4 equal to 0. What you want to do is you want to isolate 10 alpha, meaning you're going to have here 10 alpha being equal to negative 4, right? There's a 5 here. Divided by 5 on both sides, you're going to have negative 4 over 5, like that, you see. So now because you can see that 10 alpha is like a negative value over here, like this is practically saying opposite over adjacent, you see, opposite over adjacent, because that's the ratio for 10. Because remember, sine, cosine, tan has different ratios. So because you're seeing that this is like a negative value, like remember this negative here could easily have been written, or you can easily think of it as a number, as a sign in front. So you don't know if it's for the top number or the bottom number, it doesn't matter. But then if you're gonna draw your sketch, you just have to be logical, you know, because if your 10 alpha is equal to negative 4 over 5, I mean, like this is almost like one of those dilemmas, right, where you could be thinking to yourself, but then wait a minute, what if I put it over here? You see, if you put it over there, you're gonna end up with like opposite, which is like a 4, or rather this would be like a negative 4, and then you would end up with like adjacent, which is like a negative 5, you see. So you would know that, okay, wait a minute, this won't work out, because if you put it in here, then you have a negative and a negative, which will cause a plus, of which that's not what we have. So this won't work. So from there, you will now know, okay, fine, it looks like your triangle has to be here. So you'll always draw your line, and you always make sure your dotted line here goes to the x-axis, always and forever, you see. When I say always and forever, I literally mean always and forever. So then the other thing now is, now we can put in our values, right? Opposite is going to be negative 4. Oh no, negative 4 is not doing the things. Let's use a different color. Negative 4 here. So let's write negative 4. And then here now, positive 5 makes sense. You see, because this is a positive side of your Cartesian plane, or whatever you want to think of it. And then alpha, you can put it over there. Now, before you do anything, I always say, always try and get this length here using Pythagoras, right? So you can label it, let's say r squared, and then it is equal to 5 squared plus the negative 4 squared, like that, you see. And then you're going to have here 25, and then plus 16, and then you're going to have your 40, 40 what? No, 41, 42. What is this? I don't know, 42, I think. I'm forgetting. I'm having a blonde moment. But yeah, 25 over 16, it's going to give you 41. So square root of 41 is like what you're going to have over there, right? So it's r squared. And then if you square root both sides, you're going to end up with square root of 41, of which that's the number you can put over there inside your sketch. Square root of 41, like that. Perfect, perfect. Anyways, with all this being said, oh, how did I miss this picture? Oh, wait, hold on. Is there anyone that's like in the waiting thingy? Nope, everyone is here. Anyway, so yeah, with what we've just written down here, we're good to go, because if they're going to ask us to get a value for 1.1 here, right, all you have to do is, you don't want to panic. You see, like 2 cos 180 minus theta, no, minus minus alpha, sorry. Getting this expression here, you can always just use the reduction formula, because the reduction formula will tell you what to do with a 180 minus. You see, because you see your cast diagram will always help you there. So let me crop this out so we can just do our 180 minus, just to showcase where the ratio for 180 minus comes from. So with about 180 minus, we would be thinking to ourselves, okay, our cast diagram, CAST, 180 minus would be in this quadrant. 180 minus alpha, right, is in this quadrant. So if 180 minus is in this quadrant, cos is a negative there. So here you know that this is going to be 2 multiplied by negative cos alpha, which is just the same as negative 2 cos alpha, you see. So from what you've written down here, your last step is now you can use your triangle to work this out. So from your triangle, cos is just adjacent over hypotenuse, right? So where the cos alpha is here, you're just gonna throw there, according to your sketch, you're just gonna throw there adjacent over hypotenuse. Adjacent over hypotenuse. Let me do this here, 41, like that. Let me actually make this a bit white, and then close the bracket. And then all this you can just put in your calculator, right? Like -2 bracket, and then you have what? 5 over 41. Yeah, man, 41. Everything close bracket, you're gonna get the, you can just write it the way it is in the calculator. 10 square root of 41, and then 41 over there. There you go. That's that for that question. So if there are no questions for that one, I think we can quickly go through the last 2 that we sent, that were in here, and then we shall see. Let me see here. 1.2, 1.2. Yeah. So if there are no questions for 1.1, we can just quickly move on to like 1.2 here. For 1.2, we can see that we don't want to overthink anything, you know. The reason why I say you don't overthink anything is just look at this as though they're telling you that you have sine alpha minus 90, and then sine alpha minus 90 again. You see, like that. And then here you have minus sine alpha, but then it's being multiplied by itself. So I'm doing this deliberately. But then I think the sine part, I don't think this one is necessary. Like, it's really not. Let's just leave it as sine squared. So the reason I did this is so that you can just remember that your reduction formula just applies for each of them individually. So normally what I like to do is I like to view these things, I like to view these angles swapped around, you see. So here you're gonna have the -90 plus alpha. I'll show you why just now you want to view them swapped around. So here you're gonna have -90 plus alpha, and then minus sine alpha. So we're working with negative angles here, right? So remember, anytime you work with a value that's a negative, right, and you're trying to use the cast diagram, because the cast diagram is what's going to help us to like simplify whatever we need to simplify. Meaning, if you look at what we have, right, -90 plus alpha is going to look as follows. So you're going to have here, remember, this is like 0, 90, 180, 270, and then 360. Now, anytime we're going clockwise, it means we'll be using negative, because normally we go anti-clockwise, right? We go from 0 to 90 and then 180. This is us going anti-clockwise, you see, when we're using like a positive value. So when we say stuff like 180 and then minus, we always end up here, you see, because anytime you say a plus, you'll always see yourself going this way. But then anytime you minus, you'll always see yourself going back now. That's why, for example, 180 minus ends up here, you see. 180 plus ends up here because 180, and then if you keep plusing, you're going to end up in this quadrant over here, you see. And then if you're going to go here, we know that you say 100 and you say here 360, and then the moment you minus, we know you go in the other direction. That's why you end up over here. So what I'm saying is, looking at our cast diagram, right? Anytime you consider a negative number, you go clockwise immediately. So meaning if you're seeing negative 90 plus alpha, it's going to be negative 90 and then you plus alpha, meaning you end up in this quadrant. You see, because you went negative 90 and then you added. Remember, anytime you were subtracting, you go this direction. The moment you plus, you go anti-clockwise. So negative 90 plus alpha is in this quadrant here, where only cos is a positive, you see. So this here, we know that it's going to come out as a negative cos alpha. The reason I'm making it a negative is because only cos is a positive in this quadrant. We're changing our ratio because we're dealing with a 90. Remember, the only time we go from a sine to a cos is if we're dealing with 90. The only time we go from cos to sine is if we're dealing with a 90. So with our previous example, here we were dealing with a cos, right? So from a cos, we were able to go to a cos as well because of the 180. But the moment you deal with a 90, you always go from a sine to a cos or vice versa. And then us putting a negative here, we did that mainly because you always use this to determine what sign goes here. You see, you always use where you're coming from. So using where we're coming from, we can see that in our cast diagram, negative 180 plus lands you in this quadrant, right, where only cos is a positive. Because remember, your cast diagram says CAST, you see. So only cos is a positive here. So sine is not a positive in this quadrant. That's why we put a minus. And then because we're dealing with the 90, we put a cos over there. And then you can imagine we're just going to do exactly the same for this. You see, it's also just going to be negative cos alpha. And then here you have minus sine squared alpha. Simplifying some more, you're going to have positive cos squared alpha. And then here you're going to have sine squared alpha, you see. So before we even carry on, our questions here were just asking us to determine without a calculator. Oh, it's fun how they say determine without a calculator, but we use the calculator here. The fortunate thing is, if you, as long as your steps are all there, right, you won't be penalized for like what we just did there. So with this question also, before we even worry about doing anything here, we wanted to break it down as best as we can. Because the moment we've broken it down, our right angle triangle is useful again. Because here we just need a value for cos alpha. Cos alpha is adjacent over hypotenuse, right? So let's put here adjacent over hypotenuse. This whole thing is squared. And then here sine alpha is opposite over hypotenuse, which is -4 over square root of 41. So please take note of how, for example, here, brackets are what is like helping us, because the moment we don't put brackets to like do stuff, yeah, that's already a recipe for disaster. So here, maybe if we don't use a calculator here, it's going to be 5 squared, which is just 25. Square root of 41 squared is going to give you a 41. And then here a negative and a negative will just give you a plus. So then this is what you'll have. And then I promise you, as long as you have all this written out here and you have all this done, you can just throw this in your calculator. You see, because these words here, all they're trying to do is to tell you that just show your steps before you put in stuff in your calculator, actually. Because I mean, like, hypothetically speaking, the only reason why they are saying without using a calculator is because they want to see the steps and all that. So with all this being done, this you can just throw it into your calculator. because there's hardly any way of telling whether you did it with your head or if you did it with the calculator. So the final answer here is just going to be 25 plus 4 square root of 41, the whole thing over 41. And then yep, question.
I have a question.
Away.
What happened to the square root on negative sine squared alpha?
Sine squared alpha. You mean?
Oh, I meant the squared. Into the squared.
Oh, the squared. Oh, okay. Yeah, you're right. That was actually an error. Thank you. Ha ha ha. So this has to go. So let me remove all this, and then just put the square. So yeah, as you can see, you can easily leave stuff out. So if your answers are like not working out, or I think the idea here is you can always just double check what you're going to write out before you like move on. So here we can even remove the plus here for now and keep the negative and just use brackets first. So negative 4 squared is a 16. Square root of 41 squared is going to be a 41. And then now this you don't even need a calculator for, because there's no negative. This is just going to be a 16. The bottom part is going to be like a 41. And then here 25 minus 16 is like 9. So that's like 9 over 41. There you go. That's the way. I like it. Oops. That happened. But yeah, that's the idea with this question. I think we could move on to the last one and then call it a day. And then what was sent on the Euclidean side, whenever you're working on it, feel free to hit me up, and then I'll be able to do the things. So if there are no questions on this question that we just did, we're just going to do this last one, and we're all just going to go our separate ways, So this question here, right? It says determine the value of x if this left side is equal to 0. So it's a solve for x kind of question. Solving for x here, the issue is that, well, I don't want to say there's an issue actually here, because 1045 in your calculator or using the special triangle, 1045 is just going to be 1 square root of 2. So here you're going to have 4 cos squared x, and then 1045 is opposite over adjacent. So that's just a 1. So solving for x here, we can just take the 1 to the other side. It becomes a positive. And then divide both sides by 4. And then shift cos the quarter. So that's like, so here, the square part, obviously you want to deal with that. So you're going to square root this side, and then you're going to square root that side. So that's going to give us cos x equal to 1 over 2. And then now you can solve for x. Solving for x, you have shift cos half over there. So the only thing is, actually, right, before we even get carried away, let's not do that. Before you find yourself doing any shift cos stuff, always get a reference angle first and then solve for x. Otherwise, yeah, it's not going to be on. So from here, we can get a reference angle, right, using the whole shift cos a half there. And then even if this was a minus, right, always use the value only, and then use the sign to choose a quadrant. So we're going to showcase that just now. So having to have done all this in our calculator, right, shift cos that half there, shift cos a half is like 60. So your reference angle here, reference angle is equal to 60. Because once you have a reference angle, now you can use the sign in front of your number over there. So the sign in front of our number is just a plus. So since the sign in front of our number is just a plus, then we should ask ourselves, okay, where is cos a positive? Cos is a positive in this quadrant and in this quadrant. So in quadrant number 1, it's just a matter of saying x is equal to your reference angle. X is equal to 60. Because we're not getting the general solution, we don't have to But we may have to, because this here is important, right? As long as there's a domain given, or even if there isn't, I think a good habit would be to always put the plus k 360 k is an element of integers, and you'll see why just now. The fourth quadrant, we know we're going to have, let me leave some space here and do this at the bottom. You'll see why just now. So the fourth quadrant here, we know that we are going to say x is equal to what? The fourth quadrant here is 360 minus your reference angle, 360 degrees minus the reference angle. This is going to give us 360 minus the reference angle, right? This is going to be 360 minus the reference angle, and then plus k 360. K is the element of integers, right? So this is going to be like 300, and then plus k 360, and then k is the element of integers. And then you are done. Well, you could assume that you're done, but then, I mean, you know, you never know. You never know. But then at this point in time, yeah, I think you're definitely done, because there's no other answers that can come out from what you have. When I say there are no other answers, I mean, anytime you have a domain given, right, all you want to ask yourself is, if you were to throw in a random integer for k, are you going to get another answer that you don't already have? For example, if you throw what you call a negative here, it's not going to be, your answer is not going to be in this domain. You're not going to get a valid answer. If you throw a positive one here, it's going to be it's not going to be within the domain. If you throw a 0, you already have the 60. So whatever we do here, right, whatever value you're going to throw in for k to try and get more answers in your domain, I don't think you're going to get anything else, because even here, if you put a 1, you're not going to have an answer within this domain. If you put a 0, you already have the 300 anyways. So as a conclusion here, these are just your answers, right? The 300 and your 60. You can then say here, if you want, therefore, x is equal to 60, or x is equal to 300.
Yeah, you're making noise.
And then you're done with this question. So if there are questions, you can ask them before we all just disappear. So this is what you have to do for questions that will be asking you to solve for x. You don't have to stress too much about them. The more you're gonna bump, the more questions like this you're gonna bump into, the easier they get. That's basically the fortunate thing with math, because it's always about pattern recognition, if I can put it that way. So if there are no questions, then I think that will be that for my side. I mean, based on what we did here, if you don't have any objections on what we looked at here, then I think that is that. You know, we can all go